Decimal expansion of real numbers. We have learnt about the real numbers. Now we will look at the decimal expansion of real numbers. By this expansion, we can distinguish between rationals and irrationals. Let us first take rational numbers. We will find the decimal expansion of these three numbers. Here we can see that on decimal expansion, the 10 by 3. Here we can see that on decimal expansion of 10 by 3, we get remainders 1, 1, 1, 1, 1. Similarly, the decimal expansion of 7 by 8 gives remainders 6, 4, 0. And remainder of 1 by 7 is 3, 2, 6, 4, 5, 1. Decimal expansion of real numbers too. Did you notice something here in all these examples? Notice that here the remainders either becomes 0 after certain stage or starts repeating itself. Let us go through these cases one by one. Case 1 is if the remainder becomes 0, then the decimal expansion ends after finite number of steps. The decimal expansion of such numbers is terminating. Case 2 is, if the remainder never becomes 0 or repeats itself, then the decimal expansion of such numbers is non-terminating recurring. Example. Let us now have a look at one example. 1 by 3 is a rational number. The decimal expansion of 1 by 3 is 0.3, 3, 3, 3, and so on. And we can see that 3 is repeating here. We write it as 0.3 bar. Let's take another example. Decimal expansion of 1 by 7 is 0.142857, 14285, and so on. Here 142857 is repeating. So we can write it as 0.142857 bar. Hence, if a number is rational, then its decimal expansion can either be terminating or non-terminating recurring. In other words, if the decimal expansion of any number is terminating or non-terminating recurring, then the number is rational number. And what do we call the numbers whose decimal expansion is non-terminating, non-recurring? Those numbers are irrational numbers. For example, square root of 2, pi, etc.
For more such videos on all subjects, practice questions, and a lot more, download iPrep and learn unlimited.